I'm Steven Roy Goodman, host of Higher Education Today. Welcome back to the education program that connects you to contemporary issues, people, and institutions involved in the world of higher education. Today's show is a special joint production of the University of the District of Columbia and the University of Cape Town. I'm here in Cape Town, South Africa, where we'll be talking about mathematics in Africa. Barry Green is Chief Research and Academic Officer at the African Institute for Mathematical Sciences, which is also known by the acronym AIMS. Chika Yinka-Banjo is a lecturer in the Department of Computer Science at the University of Lagos. Chika recently earned her PhD here at the University of Cape Town. Welcome to both of you.
Thank you very much.
Thank you.
Well, maybe if we could start with you, Barry. What is the African Institute for Mathematical Sciences?
The African Institute for Mathematical Sciences is a network of centers of excellence in mathematics and its applications. It focuses on training, research and outreach in these areas, and it grew from an original center which is in Cape Town, Muizenberg. It was launched in 2003. And since then, we have had centers opening in Senegal, in Ghana, in Cameroon, and last year in Tanzania. It involves postgraduate training, mostly at the master's level. And Chika, who is here with me today, was one of our students in 2010, and it's great to be together again.
Thank you. Yes, I'm a product of African Institute for Mathematical Sciences. I started the program in 2009, and I finished in 2010. I had a great experience. It was actually the genesis of my progress in academia.
And you're now a professor or you're a lecturer at the University of Lagos?
Now, I have been a lecturer at University of Lagos before I went for the program. I registered for a PhD. That was what led me to go to African Institute for Mathematical Sciences. I didn't have a research topic. I looked for how to get a research topic, but there was nothing to research on because, depending on your background and your environment, that was what made me to start searching for something higher and something that can give me the idea of what to work on as a PhD. Because for PhD, you're supposed to bring something new, an innovative idea that you can bring out there for people to learn from and to be used. So that was a friend of mine, that's a colleague of mine in University of Lagos, where I used to work, and I'm still working, told me about AIMS, that it's actually a research institute where you can go and learn some things in mathematics. They will house you in the environment. You stay there with the lecturers. Then you do a lot of rigorous mathematical training. And after that, there's no way I will come out without having a research topic. And come to think of it, they were supposed to give me a postgraduate diploma at the end of the program, which was supposed to be 10 months. And I already had what I called masters. And after doing the masters, I still didn't have anything to do. And I said I was going to go for it. But I applied. The first thing was to apply, and I applied, and thank God they took me. That was the first step. When I was given the admission, I knew I was going to go for it because I needed to move forward in my career. Since I've been in the academia, I needed to move forward in my career. Then I took the challenge. I had some kids, 2 children, but I was supposed to go alone. I had children and a husband. So I moved to the institute. They sponsored us, which was the good part, because of course that was another aspect of challenge, how to move to Cape Town from Nigeria, where I work. So they sponsored us. I moved to Cape Town, and I did the program for 10 months. And at the end of the 10 months, I had a research interest and a research topic.
And your research topic is about robots?
Yes. In AIMS, we have three phases. We have the first phase, which is the skill courses. You learn some skills, learn how to program, you do it practically. You are entitled to a system yourself. Then you work with other people from different countries. You work with high-class lecturers from different parts of the world. Then after the first phase, which is the skill courses, we move to the second phase, which you can call second semester. We call that the review courses. There you can start moving to the areas where you have interest. We have a lot of courses. You select some courses that are of interest to you. So I chose some courses that, because I had this computer science plus mathematics background, I actually work in the Department of Computer Science. So I chose some courses that had to do with my line, my area. Then at the last phase, which is supposed to be the essay, or what we call, or what you can call thesis, we call it essay in M's because it was supposed to be for 6 weeks then when they were doing the postgraduate diploma program. Now it has been changed to master's, which is now more than, which is now 3 months. So I saw some research topics, which was my major aim of going. I saw some research interest in robots, and when back home we used to think a robot is one out of the world thing. But because of the kind of things we have learned in it, because of the mathematical, is applying mathematics to robots, actually. Robot is just a machine, just like computer. But it is what you put in that will make it work. It's the software aspect of it. So I went into that, and we did I did a thesis that has to do with knowing how robots navigate without colliding with any obstacle. So we just did that by experimenting using a mathematical model called Bayesian network, which is actually a probabilistic model that we use to check how robots can navigate without colliding with any obstacle. At the end of the essay, we realized that our model worked perfectly well. In fact, it gave us 100% when we used the environment that we simulated. But when we moved it from that environment to another environment, it gave us a very potential result that will make the model work for almost all the static environments. That I got interested with my supervisors, and they agreed to supervise my PhD. And that was how I got interested in working with robots.
Well, that's very interesting, because you mentioned the issue of the applicability of the robots not crashing into each other.
Yes.
And maybe I could ask both of you this. I was recently in Northern California, where I went to Google, and they are working on these cars that are self-driving cars. And if you think about it, that's an interesting idea. But one of the things, if you were on the road in Northern California, you would hope that those self-driving cars wouldn't crash into themselves or other people or other cars. How do you make sure that that happens?
That's where the modeling comes in, and using mathematics to work. Because when I mentioned that we used a model, we used a Bayesian network model. Then that was to test it. And this network has to do with probabilities. What's the probability that we actually was a behavioral model? What's the probability of seeing we use obstacles as we put a lot of obstacles in the environment, and we use that obstacles to test if the robot will go. What we did was actually, what's the probability of the robot moving in within these obstacles, within this environment that is unstructured. Unstructured is the word, because you have different things. You don't know that it's supposed to be this. How would he move in this environment without colliding? So what we did was we now made those structures as obstacles, and when the robot sees a lot of them, he moves towards the farthest one. So we take the probability. So the robot will move towards the farthest one, and as he's moving, before you know it, it gets to his destination, and it's getting closer to the farther one. That's the farthest one. It takes a threshold that it stops and read again. The robots, they have sensors where they perceive, they take information, just like human beings. We use eyes to see. They have sensors that make them see. They have sensors that make them hear nowadays. They have sensors that make them perceive, as in with nose, smell. So for our own, we have this sensor that make it to just take the reading of what it sees in the environment as obstacles, so that it cannot collide with others. So in so doing, it navigates without colliding. So the essence of, like what you said about how do you do that, it's modeling. It's using mathematics, turning mathematics into programming.
Yeah, maybe I can come in there. So mathematical modeling underpins a lot of what is done at AIMS, and particularly in the research phase, where there are supervisors from many, many different universities in South Africa and outside who actually lead a project. Now, there have been projects of many different kinds. Some of them relate to disease modeling, for example. There's a Center for Epidemiological Research close by, and there are many experts that visit that, and they have data, real data, and that plays a role in modeling the HIV prevalence, in modeling tuberculosis, various disease modeling activities. That's one of the areas. Another might be in climatology. We've had students who have worked on projects related to pollution in the township areas. But of course, we also have projects which are simply curiosity-driven in theoretical physics, in pure mathematics, and with the view to enabling talent in Africa to contribute to the growth of Africa and solving Africa's problems. So AIMS is a hothouse of activity. It's a 24/7 type of environment. Our students, as Chika is coming from Nigeria, come from all over Africa. We are careful in how we select. We have a rather large pool to select from. This year there were 2,700 applicants for about 250 places, which is a very big number, and we have a team of people that carefully screen these applications to finally make an acceptance. But I would say the biggest and most important feature of AIMS is the spirit at AIMS. This is the spirit of growth, the spirit of contributing to a new environment in Africa and being able to solve problems for Africa by young talent.
Well, maybe if we could speak to that issue of the young talent. So let's assume there's a mom or a dad somewhere watching this segment today, and they have a teenage son or daughter. What would you like to see that teenage son or daughter study now or tomorrow, so that way they would be ready for a program like we're talking about?
Well, certainly they need to do what they're interested in. That's always the most important. But of course we have to provide an environment, and for those who would like to spend time at the African Institute for Mathematical Sciences, they would need a mathematical science type background. It may be computer science, it may be statistics, it could be engineering, electrical engineering, physics, pure mathematics. All those areas we feel lie at the base of a lot of scientific activity and underpin a lot of what is done in new inventions and in analysis of existing situations. And so we would advise a young person to take a basic degree in a mathematical science, but the distinction between what happens at a regular university and in our institutes, which are centers of excellence, is that we have faculty that come from all over the world. They come for short periods. They spend 3 weeks at a center typically offering a course. This means that we can be very flexible. We can offer new topics like robotics, like image processing, medical research topics in physics, and so on.
But I was referring to the even younger student than that.
Right.
Now you're talking about the student who's already at a university.
Right.
I was interested in both, perhaps. Right. Maybe we could talk about what would you like a teenage student to study, to get ready to university, and then they're at the university?
Well, I would, for a teenage student, I would definitely recommend that they take the math type subjects, the general science type subjects, physics, chemistry, and of course computing, problem solving using a little bit of computer science or familiarity with that. So definitely a science type program, I would say, at the school level.
And Chika, do you agree with that?
Yes, I do. I agree that they should start, it's about interest, like you mentioned before. You must have a passion for stuff that you want to do. But if you're going to be in science, mathematics is the foundation. You have to do mathematics from your primary school level, secondary school level, and as you go, for you to have the passion, and you have to practice for you to be able to achieve that.
That's a fair point. Well, I'm going to say publicly something I've never said before. I was actually a mathlete when I was a student. My wife has a little trophy of mine, but not many people know that, but now they will. So I was a proud mathlete when I was a kid a long time ago, and so I enjoyed our math team very much. So I think that the work you're doing is important. In terms of, you mentioned, Barry, about African views of kind of African issues. Is there such a thing as African mathematics versus Canadian mathematics versus French mathematics?
No, I don't think so. I think mathematics is universal. It is one of the, it links people, in fact. It's, 1 + 1 is 2, whether you are in Japan or China or in the US. But, of course, there are many challenges we face on our continent, and some of them may be to do with the roads, for example. You just need to travel in Douala, in Cameroon, to realize that we've got an enormous challenge in designing proper networks. And so there are challenges that are faced in Africa that are, some of them, unique. They are unique to a developing world. And where we have made great strides in certain areas, there are places where we need to work harder, and I believe mathematics and mathematical science can contribute to that. Another area would be in communication. If we have a look at the footprint, the internet footprint, then you will see how dense it is in the northern hemisphere, United States, Europe, and so on. But if you look in Africa, it is the footprint isn't very dense. There we've got an enormous job, and of course it connects people. So that requires mathematical science. So it is not, when I talk about mathematical science, it is not mathematics put in a box. It is mathematics and its broad applications into the community, in education, in new inventions, and so on.
Well, but you could see from a political standpoint that some people could question this, because there are a lot of problems, not just throughout Africa, but throughout the whole world. There are a lot of people who are homeless. There are a lot of people who are very, very poor. And meanwhile, you run this very nice center in Muizenberg, but people could say, well, we're spending a lot of money on that. Wouldn't it be better to spend the money on something that's kind of direct service oriented? How would you respond to that?
Well, my response to that would be, we need to take a long-term view of where we want to be and how we're going to get there. And to get there, we need to have well-trained people with talent who can actually help make good decisions and also help create solutions, find solutions to some of those problems. So for most families, even if you are, you might be one of a family of a first generation going to a university, most families from rural areas would like to see their children educated. That means they'd like them to get a good job eventually. They would like to be able to compete in a market which is tough, and having qualifications which are needed in order to solve problems will contribute towards that. And mathematical science is one of the areas which underpins a lot of activity. So that's where we feel an investment in this area will go a long way to addressing these problems over the longer period.
And Chika, from the Nigerian perspective, do you think that the government of Nigeria has been investing in mathematics in the same way that you would like them to?
Well, I can say from my experience, from when I was growing up, mathematics, we used to do a lot of mathematics. We have a lot of smart people in Nigeria, but the major problem we have is applying the theory that we learn to a real life situation. We learn a lot of theory. So if you talk about government helping to establish things that will help individuals to know how to put them in practice, I would say they are still in the process of getting there. Yeah, because most people have a lot, 1 + 1, this, you can quote them, you can do all that, but you don't know how to apply them to real life. So that's what I believe AIMS gave me, what I never had. Because if I had that, I wouldn't have been looking for a research topic. So I had to come to a place to get the idea and how to use what I know to solve problems. So I believe that what majorly that we are lacking is the practical aspects, and governments need to, make people think beyond the box, outside of the box, so that one thing we are taught in AIMS is mathematical thinking. It's different from mathematical theory. Mathematical thinking is different from that. So there are different ways you can solve problems using mathematics, and this, you don't get it anyhow. You get it in a place that is organized like AIMS, and not only AIMS, maybe there are other institutes that are into this kind of things, but we are yet to get there. We are still in the process.
But not everybody has the ability to go to a place that's a selective, terrific program that specializes like AIMS does. So what does a person do who doesn't get into Ames? A person who's interested in mathematics, who lives 100 kilometers from a major university in Nigeria or South Africa. What can that person do to train to be the best mathematician they can be?
If it's a passion, you look for a way to solve, to develop yourself. You keep solving problems, you keep reaching the internet, you keep getting through with people across the internet. You keep trying to widen your perspective in that area. You just keep going as far as it's a passion.
Maybe I can come in there because we at Ames we believe that our mission is broader than just the students that we train every year. We have an outreach dimension to our activities, and one of those outreach activities is teacher training, professional development of teachers. And so over the past 10 years, we've reached more than 1,000 teachers in rural areas in South Africa. During their holiday periods, they come through for special courses and are trained by trainers from South Africa and elsewhere. And during their teaching time, we have set up satellite stations in different parts of South Africa, and the teachers gather together, and there's a one-on-one interaction with a lecturer based at one of our centres, or at Stellenbosch University at times we've done this. They've allowed us to use their facilities. And so in this way we reach far more people. We also have brought school learners to the centre for special activities. That some of them might be workshop related and so on. But this program the success of this program has led to it being replicated in Cameroon now. And that is supported, we've got a funder that's supporting that, and we're opening up a teacher training facility in Rwanda to play that kind of outreach role.
Well, you just mentioned Cameroon and Rwanda. It might be worth us saying a word or two about Barry. You and I met in Senegal at the African Higher Education Summit. Why did you go to that summit, and what did you get from that summit?
Well, I went there because we believe that Ames is an important role player in the transformation of Africa in the education and its application sector. I got a lot out of it through meeting people, talking to them, interacting and finding out what's happening in places like Nigeria, actually in Burkina Faso, in Rwanda and elsewhere. By establishing these contacts and forming a part of a bigger network, we are able to work together to address problems. One example I'll give you is we have interaction with the University of Makerere in Uganda. Through that interaction, we work with lecturers there. We are part of their evaluation system. They play a role in our evaluation system. And so we share our expertise, but also our problems. And in this way, we are able to collectively address a bigger issue of development in Africa.
If we can get to Nigeria for just a second. Nigeria, I believe, is now the biggest economy in Africa, if I'm not mistaken.
Right.
And given that that's true, can you just walk us through some of the jobs that a mathematician could have in Nigeria, aside from, let's say, being a lecturer at a university?
Well, I think there are many places they could work. I mean, wherever you need to do modeling. So, for example, in conservation, you want to conserve different areas, your national parks. You will need statisticians. You will need people that can monitor movement of animals or movement of or the environmental impact of whatever, of industry and so on. You need modeling to inform you about that. So you'll have people working in those areas. You'll have people working in engineering type areas where you've got modeling. But you've got new developments as well, as we see with our smartphones that we walk around with. There's a lot of technology that underpins that, and much of it is based on mathematical science. If we look at our students and where they are, our alumni, we've had over 950 alumni now, and we are very pleased that more than 100 of them are teaching back in Africa at universities in Africa. But we're equally happy to know that many of them are taking industry type jobs. And we realize that as we go forward, this is something we have to focus on. Because if we're graduating 250 students per year and we want to contribute to solution of African problems, we're going to need to get people into the industries that are doing that. And so we have an industry initiative, and we are working with partners in the industry to offer internships, ways in which our students can become involved in activities which are outside the university environment, but where mathematical science plays a role. Some of it might be in agriculture, some of it will be in the finance world, but it could be in other areas as well.
Mathematicians can work anywhere. They can solve problems in the mine, they can solve problems in the hospital, like we have the bioinformatics and biology and mathematics, that's called biomathematics. They can work anywhere because of the problem they are solving. Thank you.
If you would like additional information about Barry Green or Chika Yinka-Banjo, please visit aims.ac.za or unilag.edu.ng. If you have comments or suggestions about Higher Education Today, please send an email to our viewer mailbox at highereducationtoday@topcolleges.com. Thank you for watching. We will continue to bring you quality discussions about important matters in today's college and university world. Please join me again for another edition of Higher Education Today. I'm Steven Roy Goodman, and you've been watching Higher Education Today.